Hi, welcome to another Onwards and Upwards education video. This one is 8 Algebra 1.5 and this one's all about dividing terms. When dividing algebraic terms, we use fractions. As much as fractions do tend to terrify plenty of people, simplifying algebraic expressions that require dividing into numerators on top of the fraction and denominators on the bottom does actually make the process quite manageable. Knowing your times tables really helps when you're dividing terms because simplifying fractions is all about finding common factors between numerators and denominators. There's also a couple of tricks to learn about powers. First, let's try and remember what prime numbers are. When trying to find common factors between numerators and denominators, what you're looking for is a prime number. A prime number is a number that's greater than 1 but is only divisible by 1 and itself. Here are the first few prime numbers. These will be the most useful ones to look out for. You might remember that the numbers that aren't prime are called composite numbers, so they're all the other ones. Let's start with a few expressions that we can simplify without even needing fractions. Hopefully some of the time you'll be able to divide the terms in your head without even needing fractions. For example, if you're asked to simplify 12p divided by 4, you should recognise that 12 divided by 4 is 3. As for what to do with the pronumeral, well, the pronumeral stays with the answer unless it gets cancelled out, which we'll look at later. So in this case, 12p divided by 4 can be simplified to 3p. Now let's try some more of those. Let's simplify the following expressions. So the first one, 16f divided by 4 gives us 4f. 21h divided by 3 gives us 7h. 25m divided by 5 gives us 5m. And 18k divided by 6 gives us 3k. So simple expressions can be written as fractions too. It's just as correct and means the same thing to write the first line of the expression as a fraction. For example, instead of 16f divided by 4, you can write 16f on 4, and then we simplify that to 4f. Or, instead of 18k divided by 6, you can write 18k over 6, and then we have 3k. You can use fractions to deal with larger numbers. For example, if you're asked to simplify 55t divided by 10, if you write it as a fraction, you can then deal with a numerator and a denominator. At this point, you then look for a common factor, a number that the numerator and denominator are both divisible by. In this case, we can use 5 as our common factor, and then when we simplify that one down, 55t divided by 5 gives us 11t, and 10 divided by 5 gives us 2. So that's a simplified version of that expression. Let's practice that some more. So in this one we've got 64m over 18. And so what we can have a look at here is a common factor that is 2. They're both top and bottom divisible by 2. So 64m divided by 2 gives us 32m. And 18 divided by 2 gives us 9. So the simplified version of this sum is 32m over 9. And in the second one, 36n over 27, a common factor here is 9 because they're both divisible by 9. So 36n divided by 9 gives us 4n, and 27 divided by 9 gives us 3. So what if the pronumeral is on the bottom? You won't probably come across too many of these until you study algebra again in later grades. But if you do, it's important to remember that for your purposes, if the pronumeral is with the denominator, it needs to stay on the bottom with the denominator. Sometimes this means you still need to put a 1 as the numerator in order to keep the fraction. For example, if you've got 18 over 6t, alright, then we can divide both of those by 6, that's a common denominator, and we end up with 3 over t. And in this example, if we have 6 divided by 18t, so we sort of flip this fraction around, alright, then we have to again divide by 6, but we need to keep at least a 1 on the top. Alright, so 6 divided by 6 is obviously 1. So we can simplify this down to 1 on top, and 18t divided by 6 is 3t. So our simplified version of this one is 1 over 3t. Right, it means something completely different if you just write 3t. So we've got to make sure that we keep the 1 on top just to make sure that things are correct. And what about dividing when there are powers involved? If you're asked to simplify an expression that involves powers, you'll need to think of the pronumerals as having common factors too. Remember that x squared means x multiplied by x. So dividing is like reversing this or cancelling out the multiplication. For example, in this one we've got 18t over 6t squared. So we can use 6t as our common factor here. So we've got 18t divided by 6t, and that gives us 3, because the t's cancel one another out. And then on the bottom, 6t squared divided by 6t. Alright, we've only cancelled out one of the t's, alright, and there were 2 multiplied t's there. So we can't cancel them both out, and what we're left with on the bottom there is just t. In this second example, 24n squared divided by 6n. So the common factor here is 6n. We can divide both top and bottom by 6n. So we're going to divide 24n squared by 6n, and that gives us 4n, because we've divided the 24 by 6, that gives us 4, and we've divided the n squared by n, which leaves us with just 1n. And on the bottom, 6n divided by itself gives us 1. Now when the 1 is on the bottom, we don't need to keep it there. Alright, so the rule goes that you can then write that in its most simple version as just 4n. Now there will be times when there are multiple pronumerals and multiple powers involved. In these situations, despite the problem looking more complex, the first step in simplifying is still to find a common factor. Once you've done that, it's just a matter of applying the rules. So in this example, 36p squared divided by 27pr. So you're still all the time looking for a common factor. In this case, 36 and 27 are both divisible by 9. So 9 can definitely be part of the common factor. Now they've both also got at least one p in them. So you can add that into the common factor as well. So our common factor here is 9p. So we divide 36p squared by 9p, and we end up with 4p. And then if we divide 27pr by 9p, we divide the 27 by 9, which gives us 3. And then if we divide pr by p, the p's cancel each other out, so all we're left with is the r. So 4p over 3r is the simplified version of this expression. In the second example, 15db squared over 70d squared b. So what we can use here is our common factor is 5 for starters, because they're both divisible by 5, and then each top and bottom has a d and a b in it, alright, albeit in some cases they've got more than one. So in this case our common factor can be 5db. So we're going to divide the top and the bottom both by 5db, and on top we end up with 15 divided by 5, which gives us 3, and db squared divided by db, which cancels out one of the d's and one of the b's and just leaves us with a b. Then on the bottom we've got 70 divided by 5, which gives us 14, and then d squared b divided by db leaves us with 1d, because one of the d's is cancelled out and the b's cancel each other out as well. So the simplified version of this expression is 3b over 14d. Now how about trying a word problem? Let's say that for the new school year, a teacher buys 5 boxes of pencils. Each box contains 6 packets, and in each packet there are p number of pencils. For a class of 22 students, let's write an expression to show how many pencils each student is likely to get. Alright, so sometimes the easiest way to attack these kinds of problems is to write down what you know. So you know you've got 5 boxes of pencils, and there are 6 packets in each box. And P is the number of pencils in each packet. And then you've got 22 students in the class. So 5 times 6 times P is going to give us the total number of pencils. So the pencils in each packet times by the packets per box, and then multiplied by the number of boxes of pencils there are. So 5 times 6 times P, that gives us the total number of pencils. And there we get 30p. So if we say, alright, we need to divide the number of pencils by the number of students in the class. That's how we come over here and we have 30p divided by 22. Now when we're looking for a common factor here, they're both divisible by 2, and that's an easy place to start. So you divide 30p by 2 and you get 15p. And you divide 22 by 2 and you get 11. So the simplified expression to represent how many pencils each student is likely to get is 15p divided by 11. Let's try another one. Sarah's science class has been split into groups to do assessment for the term. In total, they'll complete 3 reports, and each of these has 8 paragraphs. The paragraphs will have an average length of X number of words. Now, if there are 5 people in Sarah's group, write an expression for how many words they should each be responsible for throughout the term. So, the total number of words in all of these reports is going to be 3, which is the number of reports, multiplied by 8, which is the number of paragraphs, multiplied by X, which is the number of words in each paragraph. So 3 times X, or 3 times 8 times X, gives us the total number of words. And then there's 5 people in the group. So when we're writing an expression to find out how many words each person should be responsible for, it looks like 3 times 8 times X on the top, divided by 5, number of students. So 3 times 8 times X gives us 24X. And then 5 is the number of students, and that's our expression. Now this example draws on your knowledge of measurement too. So rectangular shoe boxes are being packed into a shipping crate. The shipping crate has the dimensions 160 centimeters length, 100 centimeters width, and 4h is the height of it. Then the shoe boxes have the dimensions 40 centimeters length, 25 centimeters width, and h is the height of them. So first we write an expression for the volume of the shipping crate, and we've got to keep in mind that when we're finding the volume, we need length times width times height. So in this case, length times width times height looks like 160 times 100 times 4h. And that gives us 64,000 h. So that's the big one. Next we write an expression for the volume of just one shoebox, alright, and they're the smaller numbers. So length times width times height of a shoebox works out as 40 times 25 times h, and that gives us 1000 h. Now when it comes to trying to write an expression for how many shoeboxes will then fit in the crate, we're looking at a division, and obviously we're going to write that as a fraction. So we've got the crate, 64,000 h, divided by 1000 h. Alright, 1000 h obviously being the shoe boxes. Now in this case, we're going to divide down, and the common factor here is actually 1000 h. So it divides quite neatly. 64,000 h divided by 1000 h is 64. And 1000 h divided by itself is just 1. So in this case, our answer is 64. There's 64 of these shoe boxes that's going to fit into each shipping crate. Nice work. Now you've tried dividing terms in heaps of different situations. You can handle writing algebraic divisions as fractions, dividing with pronumerals, dividing pronumerals with powers, and also solving word problems that involve division. In the next video, at Algebra 1.6, we're going to look at the distributive law and we'll practice expanding brackets.